use of the surface enhance the bond shrinking. बस खोला गड़बड़ देगी लकड़ी को तब
Assalamu alaikum, dear students. Welcome to the lecture of the quantum mechanics. In this lecture, we will discuss about the wave functions and its property. The first is what is wave function? In quantum mechanics, information about the state of particle is described by a wave function. For example, in classical mechanics, we say that what is the particle position, what is particle's velocity, what is particle momentum. These are the parameters which are used in classical mechanics to describe the position of a particle, dynamics of a particle. But in quantum mechanics, we describe the state of a particle by a wave function which is complex quantities, and it has it's depend upon x, it depend upon y, z, number of variables which is required to describe. And the function is usually denoted by psi of xt, psi of x, psi of x mean for example psi of xt if particle is moving in one dimension, psi of x, y, t and particle is two dimension, and similarly for three dimension we can add x, y, z and t in three dimension. The equation that describes its time evolution is called Schrödinger equation. Mean the equation which will describe the time evolution of how wave function will change. For example, if particle is moving along the lines, so how its wave function will change. That wave functions, that equations that describes its evolution with time is called Schrödinger equations motion. The Schrödinger equation. Now let's first discuss about the Schrödinger equation. The behavior of a particle of mass m which is subjected to some potential v of xt is described by the following partial differential equation. For example, we have a particle which is bound between under the influence of potential which is v of x and t is described by the following: h iota h cut partial psi over partial t is equal to minus h cut square 2m plus this and this whole term. This is actually h psi is equal to e psi, means h is the Hamiltonian which contain kinetic energy term plus potential energy term, and potential energy and kinetic energy term plus this is the total energy. Mean h psi is equal to e psi. This is the eigenvalues and this is the energy operator, total Hamiltonian operator, where psi of xt is the called wave function. The function contain information about where the particle is located. Its square is being the probability. Means, for example, the function will describe its nature. For example, if a particle is moving on a sinusoidal path, so we can write it a sine of x. Similarly, psi is equal to a cos of x, means the particle is moving on sinusoidal path or cosinusoidal path. The wave function contains information about where the particle is located, and this is complex quantity. So if wave function will not tell about something, its probability square, mean modulus square, will tell us about the probability density. A wave function must be well behaved. In other words, it should be defined and continuous everywhere. Means, for example, if we find are integrated in space, so psi square dx, psi square d top should be equal to 1, mean it should be defined, it should not be undefined. In addition, it must be square integrable. For square integrable, minus infinity to infinity psi mod square into dx should be less than infinity. It should not go to infinity. Otherwise, our wave function will not be square integrable. Square means if any functions satisfy this property, that will be square integrables. Now, properties of a valid wave function. What are the properties which is associated with a valid wave functions? Let's see. A wave function psi must be single valued, means each should be single valued, and the second is it should be continuous, and the second it is differentiables, and the third it is square integrable. So the first is single valued, mean for example if we look at this wave function, if we draw a line at this point, it has two values, one this and the second is this, so it is not a single values, it is two value function, so it should be single value. This is actually not a function because it gives two value at one point, at one value it gives two wave function, and it is should be continuous. For example here this there is a discontinuity in this graph, so it is not continuous. The function should be continuous, and also its derivative should be continuous, means there should be, it should not go to infinite. Function should not the slope of the slope of this function should not go to infinity, and also this function should also not go to be infinity, like there should be no breaks. For example like this is not a continuous, they are not a wave function because it is discontinuous. Similarly it should be differentiable, means its derivative should not be equal to infinites. B square integrable, mean a wave function should not go to infinity. If we find its psi square dx, it should not go to infinity, it should give some finite value because probability square, so probability should be equal to 1. Probability always remain between 0 to 1. And these are the some wave function. For example these are the this is not acceptable because it gives two values. This is also discontinuous. This is also acceptable wave function because it is continuous. This is also a continuous wave function, and this is also a constant functions, and it does not depend upon position, so this is also acceptable wave functions. We look for another types of wave functions. These are the some wave function. This function is continuous, single valued, and this is also single valued. This is discontinuous wave function, it has two breaks. And similarly this is acceptable wave function. This is not acceptable because it is not single valued. This is acceptable continuous wave function. If we draw that graph for these wave functions, psi is equal to a secant x, psi is equal to a tan x. So these graphs, these wave function graph are they have discontinuity, because you know that tan infinity gives equal to tan 0 gives equal to infinity, it is undefined. So secant x and tan x contain discontinuity. These equations are not giving the continuous wave continuous graph, so these are not a wave function. And similarly psi is equal to exponential x square. If we integrate this between minus infinity to infinity and psi mod square, so it will give infinity. So it is not a I will say that not square integral function, but this function gives some positive finite value, so this is square integrable wave function, and it satisfies all the properties of wave function. Now if we consider the example, for example let two wave function x psi and phi be defined over this, explain why psi of x is equal to x cannot be wave function. So for a finite wave function we will integrate 0 to infinity psi mod square dx, 0 to infinity x square dx. If we integrate this is giving infinity, it means this is not square integrable. But if we put phi of x is equal to exponential minus x square, if we integrate this one, it means this should give finite if this is acceptable wave function. So let's go to its solutions. If we again differentiate this wave function, 0 to infinity phi of x square into dx, it gives some finite value. You can find its phi, because phi of x is given, then you can find phi steric of x. So putting phi and phi steric of x, it will give us phi modulus square and dx. By putting this value, it gives exponential minus 2x square dx, and it is equal to under root pi over 8. Therefore phi of x is equal to square integrable because it gives finite value, and it is well behaved, and its graph is continuous. You can see its graph is in continuity. There is no discontinuity in this graph. Similarly we have another types of some graph. You can see that we have f of x is equal to 3 sin pi x, which is continuous graph. So 3 sin pi x is the continuous wave function, this 4 minus hx is not continuous and not finite and not square integrable. Similarly, h square x is equal to phi x is neither finite nor square integrable because h will be equal to under root phi x. So for negative value of x, this will not use finite value. Imaginary, it will give imaginary values. Similarly, for e of x is equal to x square, this is neither finite nor square integrable function. So these are not acceptable wave function, and you can also justify by plotting its graph. It will either not square integrable if you integrate this by putting into this expressions psi of mod square into dx. It will give infinity or minus infinity, and similarly its derivative will be not constant. If you draw the graph, it will give discontinuous wave function. So one of the properties are fulfilling one of the properties. So these are not acceptable wave function except this one, which is a continuous sine wave function. You can see that this is continuous wave function, and this first one is acceptable. Rest of all is not acceptable. So I will stop at this point and we'll again meet in the next lecture.